Hello, my AP Precalculus students. It's been a little while since I've had a chance to talk to you. Hope you're doing well. I'm coming along pretty nicely. My recovery is going pretty good, and I'm hoping to be back sometime in the near future. But in the meantime, you got to learn, and it's been a while. So let's get to work today, all right? So here we go. Let me share my screen. We're going to pick up right where we left off. Okay, I'm going to ask you guys to graph this polynomial function. Now, you know this is a polynomial because we've got terms of a sub n x to the n, where n is a whole number. So, you guys know that when you're graphing, the steps that we follow are always the same. We're going to start with our domain, but because this is a polynomial, I don't know about you guys, but I don't see any bad things. So we know our domain is all real numbers, which is from negative infinity to infinity. From there, we're going to go and do what's going to be the most important part of today's lesson, really. We're going to be focusing on x-intercepts with the other examples. So let's go ahead and find the x-intercepts for this guy. Keyword x-intercept, what does it mean? It means set the y equal to 0. So we're setting this function equal to 0. This is degree 2 or higher pretty clearly, so we know we got a factor to solve it. We're going to factor out that x, and when we do, we're going to end up with x squared minus 6x plus 9. We're going to now continue to factor because we've still got a degree 2 factor, so we're going to factor this guy. And we're looking for factors of 9 that add to negative 6. I believe that's going to be negative 3 and negative 3. So when we make the baby equations, how do we solve a factored equation? We set each factor equal to 0. We're going to end up with x equals 0, x equals 3. And this is interesting. We've got a repeated factor of x equals 3. We really don't have to write that, but I'm going to because I like the fact that there are three factors. And when there are three factors, that means there should be three solutions. Just in this case, one of those factors is going to be repeated. So therefore, one of the zeros will be repeated. Now, you know me, I like to graph as we go. So I'm going to go and start putting this graph together. I know I've got a 0 at 0, and I know I've got one at 3 so far. So where do we go next? Well, next up is the y-intercept, but that's going to be quick and easy on this one because we found the x-intercept to be 0. So when we plug in 0, we're going to find the y-intercept also to be 0. At this point in time, it's everyone's favorite. It's the trichotomy number line. So let's make a trichotomy number line and find out what's going on with this function. So for our trichotomy number line, we've got two zeros that are going to get written on here. We're going to have a 0 at 0, and we're going to have a 0 at 3. When we do this trichotomy number line, we're plugging into x times x minus 3 times x minus 3. Little thing to keep in mind is that that's really x minus 3 squared. That is never going to give a negative result. So this is really the only factor that matters because no matter what I plug into these two guys, it's always going to be positive or 0. So plugging in a negative means we're going to get one negative. Plugging in a positive means we're going to get a positive. And that's true for before 3 and after 3. So from here, we can make our rough sketch. We know that we're going to go through, we're going to be below the x-axis in this region. We're going to be above the x-axis in this region. What that means is we're going to come up, we're going to hit that intercept. We're going to have to turn around to get back to that x-intercept at 3, but we're not going to cross the axis because we're going to stay positive. So what we're going to do is we're going to bounce right there. We're going to end up having a graph that looks something like that. So let's put that graph together. Oops, here we go. So that would be our graph. That's looking pretty good to me. This is a degree 3 polynomial. We've got, and it's interesting how we say it. We have two zeros, which is correct, but we really have three answers. It's just that one of them is repeated. So you could argue that there are three zeros, one at 0 and one at 3 and another one at 3, or there are just two zeros, one at 0 and there's another one, a repeated one at 3. But what's interesting about this is the repeated factor. That takes us to a phrase that you guys are somewhat familiar with. I've heard people mention it in class. You guys should now know there's something called multiplicity. Multiplicity. Okay. And the multiplicity of a solution, we would say that this 3 has a multiplicity of 2 because it's the number of times we get that solution. So multiplicity, what we're doing is we're counting the number of each factor. In this case, we would say that x equals 0 has a multiplicity of 1, and we would say that x equals 3 has a multiplicity of 2. Okay, so for every factor you've got, you add 1 to that multiplicity value. Please keep that in mind as we work through today's assignment. Let's look at another one. In this next example, you're just being asked to find the zeros. By the way, the word roots, that is another name for zeros. So we got a key word here, zeros, which means set the function equal to 0. The roots of a function are also the zeros, just another way to say it. So as we go to do this problem, we're going to go and we're going to try to factor this. But funny thing, we're looking for factors of -9 that add to +3. And good luck to you because you're probably not going to find them. So what does that mean we need? Well, from your days of Algebra 2, you should know that there are ways to factor or solve quadratic equations when they don't factor, I should say. And the key word there, of course, is solve a quadratic equation. So what are we going to make use of? Well, we're going to make use of the quadratic formula. And what does the quadratic formula tell us? It tells us that the zeros for any quadratic or any degree 2 equation are going to be given by -b plus or minus the square root of b squared minus 4ac all over 2a. We're going to prove that when I get back because I like to do that one in person. It's so much fun. I don't want to do it on a video. But for now, you have this result. So how are we going to get the answers from this one? Well, we're going to identify who A, B, and C are. And A, remember, A is nothing more than A sub 2 in this problem, and B is nothing more than A sub 1, and C is going to be A sub 0, which means we're looking for the coefficients of the degree 2 term here, which is 1, the degree 1 term, which is 3, and the degree 0 term, which is -9. Make sure you include the signs, okay? Always make sure you include those. So that's really a +1 and a +3. Kind of don't need to say that, but it's true. Make sure you include the signs. Again, +1, +3, -9. Once we know that, the quadratic formula is in effect. So we're going to say that the answers are going to be x is equal to negative. And I like to just set it up like this. I find it easier for me to make use of some blanks to fill in. I wouldn't call these somethings because they're not the same value that we're plugging in anywhere, everywhere. But this is what I know. I know that these first two are going to be my b values, so that's going to be 3. So we're going to plug in b values of 3 and 3 here. I know my next two values that I like to plug in my a values, and those a values are these two. Okay, so I'm going to plug in the same value there. And for a, we've got a value of 1, so I'm going to put 1 there and 1 there. And then for my last value, I need to do a C value. And my C value is going to go right there. So that's going to be -9. So let's plug that in. Now what we're going to do is we're going to work with something called the discriminant. The discriminant is simply the stuff inside the square root here. It's the b squared minus 4ac. And we're just going to make sure we compute that correctly. We don't want to make any careless errors. I'm a big fan of just doing it right on top. So that's going to be 9. I got a negative negative, so it's going to be plus. And then I see 4 times 9 is going to be 36. So what do I see? I notice that x is going to equal -3 plus or minus the square root of 45 all over 2. Now keep in mind, this is really two answers, and it should be two answers. There should be two solutions from a degree 2 equation. So we're expecting two, and where are we going to get the 2 from? The plus and the minus. That's really two separate problems. But before I get into that, I happen to notice that the square root of 45 can be written in a different form. Let's take that over here. Square root of 45, how can we break that down? Well, 45 doesn't have a whole number per square root, but there is a factor in there that does. We're looking for the biggest factor that has a whole number square root that goes into 45, and we're going to use 9 times 5. So, laws of square roots, I can break this apart when there are factors into the square root of 9 times the square root of 5, and I know the square root of 9 is 3. So I can replace that square root of 45. Notice I'm not replacing anything else. Everybody else is staying exactly the same here. But the square root of 45, I can now rewrite that. And the way we can rewrite square root of 45 is 3 root 5. So from here, we get two separate answers. We're going to break this up because of the plus and the minus. So we'll bring it over here. This is now going to turn into negative 3 plus 3 root 5 over 2, and, write it like this, and negative 3 minus 3 root 5 over 2. You can go one step further with this. You can do what we call split the fraction. We got a common denominator. So this is really negative 3 halves plus 3 root 5 over 2. But we've also got negative 3 halves minus 3 root 5 over 2. You may recognize answers like this. They should make you think of a difference of squares, right? We got x plus a and an x minus a, kind of the same numbers being used. We call things that come in this form conjugates. Okay, conjugates are any time you have two expressions, and those expressions can be written as a number plus a different number, and then a number minus the same other number. Okay, so these are called conjugate pairs. And because of the plus or minus in the quadratic formula, we're always going to see conjugate pairs when we use it. Right? So these would be our zeros in this particular case. Moving on, let's take a look at this next one. Find the zeros of the roots of this quadratic. Well, again, we're looking for factors of negative 9 that add to negative 2. We're not going to have a lot of luck in this one, so we're going to go straight to the quadratic formula on this one. We know that a is equal to 1. We know that b is equal to negative 2, and we know c is equal to negative 9. So setting up the quadratic for this one, x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. Well, our value for the first value we put in is the b values, and that's those two right there. So b is negative 2, so we'll put in negative 2 for each of those. Then the next two values we put in are the a values, and those are these two guys, and those end up being 1 in this case. And then the last value is c, and that's negative 9. So let's take this for a spin and see what we get. X is equal to 4 plus or minus the square root of 4. Now we got a negative negative coming, so it's going to be plus 36 all over 2. Let's figure out what the discriminant's going to equal. In this case, that's going to be the square root of 40. But again, we got a nice number we can use in there. We can bust that up using the square root of 4 and the square root of 10. And that's just going to become 2 root 10. So from here, we go down, and what happens? We end up with x equals 4 plus or minus 2 root 10 over 2. We break that up using the split the fraction technique. We end up with 4 over 2 plus or minus 2 root 10 over 2. We got common factors of 2, so we end up with 2 plus or minus the square root of 10. That gives us two answers. That gives us x equals 2 plus root 10, and its conjugate pair, x equals 2 minus root 10. Let's look at another example. This one looks really similar, but in this case, what's happening is we made one small change, and that change is actually going to, create some trouble for us. That change is we made the minus sign there into a plus from this one. So again, we're looking for factors of 9 that add to negative 2. We're not going to find them. We're going to go ahead and we're going to use the quadratic formula in this case. A is going to be equal to 1 or positive 1. B is negative 2, and C is positive 9. Setting up that quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And what we're going to find out here is when we start plugging in, the first two values we're going to plug in are our b values. Our b values are negative 2, so negative 2 goes there and there. Next come the a values, that's a 1 and a 1. And now we have a c value of positive 9. Going ahead and looking at that discriminant again, this time it's going to be 4, and now we're going to get minus 36, which is really going to be the square root of 4 minus 36, which is the square root of negative 32. Now, we know that this is a bad thing. We know that the real number system cannot have the square root of a negative number. Well, this is the one time in AP Precalculus where we're going to extend past the real number system. So because square roots, you can't take the square root of a negative in the real numbers, you guys remember from Algebra 2, I hope, that there is something that can be done when we're talking about the square root of negative 1. And you guys learned in that class last year that the square root of negative 1 is actually known as the imaginary number. It's called I. So in the AP Precalculus, the only time we'll be talking about imaginary numbers is for this specific topic of finding imaginary roots, okay? And the reason we do that is because this is a degree 2. And in all the problems we've done so far, you may have noticed, let's back up, you may have noticed that in the beginning, when we had a degree 3, we found 3 solutions. Now, yeah, 2 of them are repeated. We had some multiplicity issues there, but there are 3 different factors, so we have 3 solutions. When we did a degree 2 here, this quadratic right here, the quadratic formula is always degree 2. But because of the plus or minus, we're always going to get 2 zeros. So a degree 2 has 2 zeros, a degree 3 has 3 zeros, although some can be repeated. Here we are again, degree 2, and what do we find out? We find out that we have 2 zeros. So we kind of got a pattern going where the degree is always going to match the number of zeros that we have. Well, in this case, we're being told right now that we've got no zeros because this is going to lead to an imaginary number, and that's not a real number. So what we're going to say is because we're imaginary, there are no real zeros. But because math has to be the same, if a degree 2 has 2 zeros for the other problems, it's got to have 2 zeros for this one. And that just means we have to extend it to the idea of imaginary numbers. So if we continue with this problem, keeping in mind that the square root of negative 1 is equal to I, what we're going to find out, let me just recopy this right here. Let's get all this going. That square root is now the square root of negative 32. Well, we can now simplify or rewrite that square root the way we did before by using factors at work with 32. So the square root of negative 32 is really the square root of negative 1 times the square root of 4 times, oh, we can do better, times the square root of 16 times the square root of 2. So let's break that into 3 separate roots. And now what do we get? Well, the square root of 16 is 4. The square root of 2 cannot be simplified, or we have to leave it. And now the square root of negative 1. This is where we're going to get our I, okay, because the square root of negative 1 is I. The way we typically like to write that is we like to write as 4I square root of 2 or 4 root 2I. But if you write it this way, you got to be really careful. You got to make sure the I doesn't look like it's inside the square root. So what does that give us? That gives us a new answer. But actually, we can start simplifying all of this. That gives us that x is equal to, this guy is going to be positive 4 plus or minus. We've now got 4I root 2 for our square root of negative 32, and then it's all over 2. So we break this into our 2 separate answers, and we split the fraction. We get 4 plus 4I root 2, both of these guys over 2. And remember that we can cancel common factors in the numerator and the denominator, so this becomes 2 plus 2I root 2. And that means the other answer is going to be the conjugate pair. It's going to be 4 over 2 minus 4I root 2 over 2, which is going to get us x equals 2 minus 2I root 2. So what we would say is we have 2 imaginary solutions or zeros. But the good news is that a degree 2 problem still has 2 zeros. I'm going to try one more problem before I give you guys a chance to try some on your own. So here's our last one today. Find the zeros of this particular function. I'll give you a second to think about it while I pause the recording. Let's see how you did with this one. We've got to try to factor a degree 5. And factoring a degree 5 is not something that is really trivial, but we do have a couple of clues that we can use. One of the things that I notice about this is sometimes when you're solving an equation, you just got to try guess and check. And I think we talked about this in one of the pre-calculus classes, not in the other one. So hopefully everybody's going to follow along here. What I want to do is whenever I have a polynomial that I'm having trouble factoring, I want to guess and check. And the way I guess and check is I'm just going to guess to see if one is a solution. Okay, if I plug in one, can I get a solution here? Well, plugging in one in this case means something to the fifth minus something to the fourth minus 5 something cubed plus 5 something plus 4 something, and that should be minus 4. There's a typo in my problem here. Minus 4, that's what we want that to be. Okay, so when I plug in 1, what do I get? I get 1 minus 1, that's a 0. Minus 5 plus 5, that's a 0. 4 minus 4, that's a 0. So we end up getting 0. Well, think about that for a second. If we plug in 1 and we get out 0, that means had we factored it, we would have gotten the solution 1. And what is the factor that the solution 1 comes from? Well, that leads us to if f of 1 equals 0, then x minus 1 has to be a factor. Now, make sure you understand this. Don't just use it and move on. It's got to make sense to you, right? The only way I can get a solution, think about it. If I ended a problem and the problem was x equals 1, what's the baby equation it came from? The baby equation it came from had to be x minus 1 equals 0. So if x minus 1 is a solution, then x minus 1 is a factor. Think about that. If x equals 2 were a solution, what baby equation did it come from? It had to come from x minus 2 equals 0. So I know x minus 2 is a factor. If x equals negative 10 were a solution, what baby equation would it come from? It would have to come from x plus 10 equals 0. So x plus 10 would have to be a factor. So by guessing and checking, if we can get a 0 out, we can find a factor. I'm going to tell you guys this. I'm not going to make you guess and check a lot. It's not really something we should spend a lot of time doing. But if you're stuck, my advice to you would be to try -1, -2, +1, +2, and see if you can get those guys to work. For this guy, we know this is going to equal 0 if x equals 1. So we know that this whole thing can be factored, and there's going to be an x minus 1 factor there, and then there's going to be another factor. Well, our job now is to find that other factor. So how are we going to find it? Well, simple. We're going to solve an equation. What are we solving for? We're solving for the other factor. How do we get it by itself? We get rid of the guy that's with it. Who's with it? X minus 1. How is it attached? It's attached by multiplication. So what are we going to do to both sides? We are going to divide both sides by x minus 1. If I can solve this equation, I'll now learn what the other factor is. But we wrote division here. There's a lot of different ways we can write division, okay? We wrote division using the fraction bar. What would happen if we wrote division a little differently? What would happen if we said we're going to divide this guy and we're going to use the long division symbol? And we're going to divide by x minus 1. Well, whatever we get here would be the other factor. So let's go ahead and do it, okay? We're going to do long division. But what are the steps to long division? The steps to long division is making this guy disappear. We always want to subtract out that first term. So what we're going to ask is, what do we multiply x by to get x to the fifth? And that's the key right there. If you want to do long division properly, what do I multiply this guy by to get this guy? So we're going to multiply x by x to the fourth, and that's going to get us x to the fifth. I got to distribute. I'm not just doing that one. I'm also doing this one. So I've also got to do x to the fourth minus 1, and that's going to be negative x to the fourth. So now we're going to subtract these guys. But when you subtract these guys, don't say subtract. Do yourself a favor and say change the signs, plural, signs, and add. So what I'm going to do is I'm going to change that to a negative, and I'm going to change that to a positive. And now I'm going to add these guys. Now, what's going to happen? Well, those are going to cancel. And I'll look out. Those are going to cancel. I've actually got 0. So what does that mean? It means I've really got 0 here. I'm not worried about that. So I got to bring down the next guy. And the next guy I bring down is going to be negative 5x cubed. So now, because I'm going to have actually two terms when I distribute, I'm actually going to carry down the next two terms, okay? That's going to be plus 5x squared. So I'm going to ask, what do I multiply x by to get negative 5x cubed? Well, that sounds like I should probably multiply that by a negative 5x squared. So let's go, let's do it. Let's distribute that negative 5x squared to both those guys. What am I going to get? I'm going to get negative 5x cubed plus 5x squared. So now what am I going to do? I'm going to change the signs and add. Now when I do that, these line up perfectly. These are both going to give me 0. So we're in that situation again where I'm going to want to bring down the next two terms. So I'm going to bring down that 4x. I'm going to bring down that 4. And when I bring those down, I'm going to get 4x plus 4. Well, what do I want to multiply? I'm sorry, I copied this wrong again. What am I doing? I copied the wrong thing. That's been a minus 4 the whole time. And I didn't, I thought I switched it. Let's go back. That's got to be a minus 4. I'm switching the wrong one. Got to be a minus 4 there. Okay. Down here, this has got to be a minus 4. This is going to be a minus 4. That's going to be a minus 4. Sorry about the confusion, but for some reason I wrote plus. That's going to be a minus 4 each time. So now this is going to be a minus 4 down here. And now I'm going to multiply. What do I got to multiply x by to get 4x? Well, that's going to be, I'm going to multiply x by 4. So let's go ahead and multiply that by 4. That's going to get me 4x minus 4 when I distribute. Now again, I'm going to change those signs and add, but I see that I've got the same terms on top of each other. So this is going to give me an answer of 0, which means I've got no remainder, which means I now know the other factor. The other factor is x to the fourth minus 5x squared plus 4. So that means I can take this guy right here and I can replace the other factor with this guy. Which means I now have a little bit of an idea of how to factor this fifth degree polynomial. So let me copy this guy, bring him down here. We're now trying to continue with this guy. Well, I've got my x minus 1. I don't want to do anything with that. My next factor, what you got to do is you got to notice this is a trinomial. And it's going to work nicely because that's a fourth power and that's a second power. So it doesn't go down by 1, kind of jump there. This is half what I've got there. And that's key because what are we looking for? We're going to try to unfoil this guy. Well, what makes x to the fourth? X squared and x squared. What makes the other part of this factor? Factors of positive 4 that add to negative 5. Well, factors of negative 4 that add to negative 5 are going to be negative 4 and negative 1. Check it if you don't believe me. This is going to get me x to the fourth. Here's where having half the exponent works in our favor. That's a negative x squared, and that's a negative 4x squared. That gets us a negative 5x squared. And then we've got a positive 4. Okay? So when you factor a problem, you're used to seeing it as ax squared plus bx plus c. The key is not that it's a 2 and a 1. The key is that whatever exponent goes here, okay, whatever this exponent is, this exponent has to be half of it. And if that's the case, we can try to trinomial and FOIL this, okay? So this exponent should be half the leading one. We're not done. We've got more quadratics here, and these are factorable quadratics. So what's going to happen? X minus 1 stays. X squared minus 4 is the difference of squares. X plus 2, x minus 2. And last but not least, we've got x plus 1 and x minus 1. We've got a degree 5. We have 5 different factors, which means we're going to have 5 solutions. When we make the baby equations, we're going to find x equals 1, x equals negative 2, x equals positive 2, x equals negative 1, and oh, look at this. We've got a repeated factor. So we've got a multiplicity going on there. So x equals 1 has a multiplicity of 2. Everybody else has a multiplicity of 1. We have a degree of 5, and our degree of 5 has 5 zeros, okay? So when you add the total number of zeros, you got to take into consideration the imaginary zeros, or they're also called the complex zeros, and the real zeros. But the sum of the real zeros plus the complex zeros has to be the degree. You could have repeated factors, you could have multiplicity going on, but it's always going to work that way. So a degree 6 will always have 6 zeros. Some of them may be repeated. A degree 10 will always have 10 zeros. Some of them may be repeated depending on the multiplicity. Um, all right, a lot of factoring going on today, quadratic formula, complex solutions as well. Hope this makes sense. I'm going to give you guys an assignment to try that goes along with this. If you have any questions, please reach out and let me know. Other than that, I hope to see you guys soon, and I hope you're doing well. Take care, everybody. See you next time.